Okay, just to look at psychogeometry, the first theorem that we'd like to look at is that all angles formed by the same chord at the circumference are equal. So it certainly means that if I'm having this one as x, then this one it will be equals to x, and this one as well, it will be equals to x. Maybe just to give an example, if this chord, let me call this chord AB, if it forms an angle at the circumference, then it comes again, it forms another angle here, it forms another angle at the circumference, right? Then it goes again here, it forms another angle like this. It certainly means that if this is 30 degrees, this will be 30 degrees, and this will be 30 degrees. Okay, coming up to the second theorem, it says an angle formed at the center is twice an angle formed at the circumference, given that they are formed by the same chord. Suppose that I was having this chord AB, the chord AB, then it goes at the center, then it forms an angle, then it goes at the circumference, it forms another angle. The theorem simply says that if this is x, this is simply going to be 2x. Then maybe putting it to practical, suppose this was my center, then I'm having the chord A, B. Then if the chord AB goes at the center and forms an angle, then it goes at the circumference, it forms another angle. Just that same chord. Then it simply says that if this is 30 degrees, this is simply going to be 60. Simply going to be 60. Why? Because the angle formed at the circumference, or the angle formed at the center rather, is twice an angle that is formed at the circumference. In other words, you are simply dividing this by 2 for you to get 30, or to multiply this by 2 for you to get 60. Okay, then we go on to the third theorem. The third theorem is saying that an angle formed in a semicircle is a right angle. An angle formed in a semicircle is a right angle. So we are saying that if the diameter forms an angle at the circumference, then that angle will be equivalent to what? Will be equivalent to 90 degrees. What are we saying? We are simply saying that if we draw a diameter here, then of course we put the center O. Then if that diameter forms any angle at the circumference, that angle will be equal to 90 degrees. Even if we form it anywhere else, to say like this, then we form another angle here, it's simply going to be 90 degrees, because an angle formed in a semicircle is a right angle, or rather an angle formed in a semicircle is 90 degrees. Then of course we come to the fourth one. The fourth one is very simple, but it's simply forming a 90 degrees again. We are saying that an angle formed where the tangent meets the radius is 90 degrees. So we are simply saying that because a tangent is a line which touches a circle at one part of the it just touches the circle once at the circumference. So if it happens that tangent, it meets up with the radius, then the angle that is formed, it is a what? It is a 90 degrees. Okay, so we come up to the fifth one. The fifth one, it says that opposite angles in a cyclic chord are supplementary, or they add up to 180. What this is simply saying is that a quadrilateral is a four-cornered shape, but then when that four-cornered shape it is formed in a circle, the whole shape is called a cyclic chord. So we are saying that the opposite angle, suppose this was x and this was y. Okay, we are simply saying that x plus y is equals to 180. Or rather, suppose this was w and suppose this was z. We're simply saying that w plus z is equals to 180. Okay, this we can demonstrate it. Maybe suppose we're having a cyclic chord. This was the cyclic chord. Okay, this was the cyclic chord. Suppose this was let's say this was 30 degrees. It will make this one 150 because both of them, they will make a total of what? Of 180. Suppose maybe this was 80 degrees. It will make this 100 degrees because we are saying that if we add this one and this one, it will have to give us 180. Then of course the last one, this part 1 of psychogeometry, it says that an exterior angle is equal to the opposite interior. Okay, an exterior angle is an angle that is formed as an exterior to the interior of the cyclic chord. So suppose this was x and this was y, and let me call this one z. The theorem is simply saying that y is equals to z. Okay, suppose this was a and this was b. The theorem is simply saying a is equals to b, because it's actually saying that an exterior angle, which is z, is equals to the opposite interior, which is y. Suppose that I was having my cyclic chord like this. This was my cyclic chord. It goes like this. Then this is the cyclic chord, just indicating the exterior angles. Exterior angles indicated here. We are simply saying that if this is equals to 30 degrees, this will be equals to 30 degrees. Right? If this is equals to 50 degrees, of course the other one would be equals to 50 degrees, but I cannot use this one. Let me try to use this one. Okay, if this is equals to 50 degrees, this will be equals to 50 degrees. So an interior angle is equals to, or an exterior angle is equals to the opposite interior.